Hello, coding students. So we are in the lesson B, Unit 3, which is talking about if-then structures. We just left the notes describing the inequalities and the if-then portion of the notes. Our first example is this example right here. I'm going to go ahead and run this program, and it's going to be an input, how old are you? And of course, if you put in 16, it has that desired output. If I run it again and I put in 19-year-old, it has a different output. And then if you go higher than 19, I'll just put in a 23-year-old, and it's a go to work. So you have three different outputs for this particular one program. And as you can see, you're utilizing the if-then structures. Here is your conditions. If that condition is true, then this is the result. Now, I put in, I think it was 16. If you put in 16, this is this condition is true, and this was the output. Now, it did not skip line 30. It did not skip line 40. The conditional was false, so then it dropped down to line 40, and that condition is false, and then it went down to line 50. So it doesn't mean that once it prints go to class, it goes right to the end in line 50. No, it continues down to line 30, 40, and 50. When I put in the age 23, it did go to line 20, and that condition is false. 30 would have been, line 30 would have been false as well, and then line 40 would have been true. And then it would have printed the desired output. Now, there are some situations in which you have to protect your code. Anyone running your program is going to try to find flaws in your program, try to get your program to crash. So the big issue here is input. Is it possible to have an age of 2000? Is it possible to have an age that is less than 0, -5? So we want to protect our code from garbage going into it. So we're going to call it dummy proofing. And typically when you dummy proof, you want to do it right after the input. You don't want to wait to evaluate to see if it's good data coming into your program. You want to evaluate it right away. So I'm going to put line 15 if age is less than, I'll go less than or equal to 0. You can't, I don't think you can be 0 years old. You're either 1 month, or you're 1 year, or you're 10 years. So I'll put a less than or equal to 0. Then if that is the case, I'm going to go ahead and just print, for now I'll just say invalid for now, invalid. And then I'll go ahead and test this out. I'm going to run it. So if I put in like -3, it's going to say invalid, but it still continues throughout the program. I don't want it to continue. I want it to state invalid, and then I want them to try again. So let's go into our print statement, and I'll just say politely try again, and then if I want to try again, I'm going to put a go to, so colon go to line, that's 10. So now I'm going to force the user to enter in valid data. If I run the program and I put a -1 in there, then it's going to say invalid, and it's redirecting the user to put a valid age in. Now, I only did it for one side. Like I said earlier, what if I'm 2,000 years old? I guess I'm going to work when I'm 2,000 years old. So we want to protect that side of the data as well. So I'm going to put, I'll say line 17, if age is greater than, if you want to Google the oldest person, what is an appropriate age? I think some of the students told me 122 years old. So I'll just put 123. Then if this is the case, if you're older than that, then I'm going to print, I'll just change it up really. And then I'll say try again as well, try again. And I will certainly go to line 10 and ask the user to put in the correct age. So now if I run it, it's protected with the negative numbers. It's going to be protected with 150 years old. It's going to keep the correct data going into your program. Okay, so I'm going to conclude this video, and then I will pick up our next example in our notes.